Plus, I'm also an incoming assistant professor at Boston University, starting this fall. Be surprised?
Surprise!
So it's recent news, very recent. Just accepted offer like a few weeks ago.
Okay.
Yeah. So today I want to talk about some past research about enabling natural interactions. So we all know we are living in a very exciting time. In the just past few decades, we see a lot of technology breakthrough, especially in the recent years, like AI is getting exploded, and like every month we have new model being released, and they're being more and more capable of doing a lot of different things. So the capability of technology is increasing and probably at an exponential rate. But if we look at ourselves, our human as a species, at least physically, we haven't been changed too much, at least for maybe tens of thousands of years. Like we still have 2 hands, we have 10 fingers, our eye resolution is still the same, our brain intelligence is probably still the same as our ancient ancestors. So you can see the gap between the human and the technology is getting larger and larger. And to bridge this gap, to help unchanged human body to able to interact and use the latest rapidly changing technology, we need a good interface. So that's why that's where our HCI researcher is coming here, and that's why we are all here today to close this gap. And honestly, the opportunities actually become greater, especially with now the explosion of AI. But designing good interface is not a trivial question. Ideally, we want to use something that we're already very familiar with to interact with the new technology. And personally, I believe that there are certain natural interfaces that are very easy to use, that are so intuitive and so grounded to our daily experience, and which requires possibly no learning at all. And we should preserve and build on those kind of natural interactions, and even with the latest new technologies. So I always like to use this example to illustrate what a natural interface is. So this is my cat, and without any training, you can figure out how to pull the door handle and open the door and going out of the room. So apparently, door handle is such a natural interface that even a cat knows how to use that. So over the past few years, my research has been focused on this idea. How can we enable natural, intuitive ways of interactions, especially in the new era of technology explosion? So it's a big, open, and also timeless question. And for my today's talk, I want to share a few pieces of my work exploring this problem, especially in some emerging technology area like AR, VR, and AI. So if we look back the history of interface design, some has clearly stood test of time. For example, like the rotary dial interface, they exist long before even before the computer has been invented. We have used them to control the water flow of a sink, and also use that to tune the music instruments. And in the digital era, we can use that to control some music, like a DJ console. And similarly, interface like a keyboard, trackpad, and also a game controller has been barely changed for decades. They are easy to learn and intuitive to use and familiar with people. So this kind of tangible, natural interface are what we want to bring into the new technology like AR and VR. So implement this technology or implement this interface in AR, VR is not a really hard thing, because we can always build the circuits or we fabricate them and just connect them to your AR, VR device. But what I'm more excited about is the camera-based interaction detection. Basically, use the camera and computer vision-based technology to recognize how you interact with the widgets. This is especially useful for AR, VR because almost all the headsets has their built-in cameras. And the benefit is that it doesn't require any hardware like a game controller. You don't need to charge them, you don't need to build circuits, and you can just 3D print some passive mechanical structure and let the camera to detect the interaction, and that's it. And it also makes it very easy to create a customized interface. But if we only use the camera to detect the interaction, there are some challenges. Just imagine the way you are interacting on your keyboard, the way you are playing with your game controller. The motion involved in this interaction is very subtle. So in order to make the detection very accurate, you need to find a way to amplify that signal to be able to detect that. So amplifying visual signal actually reminds me about the visual phenomenon called the Maury effect, as shown here. So it happens when two layers of mass structures stack together, which you might have seen this kind of phenomenon in somewhere like the window screen or some of your clothes. But most of the time, they are confusing and distracting, and people want to avoid them. But in our case, we want to utilize this phenomenon, and because as you can see in the video, it has the amplification effect. So simple movement will actually result in a very large change on the Maury pattern. So based on this principle, we designed a set of interaction primitives, a 1D translation, and a 2D translation, and also rotation. And we proposed a computer vision-based tracking pipeline to be able to accurately extract this pattern and detect the changes. And using these primitives, we designed a set of high-precision passive tangible interface that the interaction event can be tracked by the camera on the XR devices. So here a push button, and there's a rotary dial, and a slider bar, and switch, and joystick. Basically, we try to recreate lots of the classical tangible interface using this design. And you can see that all the widgets involve only very subtle finger motion, but the Maury pattern changes drastically, so it can be detected robustly. And here we show an application of an audio console, which has a push button, a dial, and a slider bar. When the user wearing an XR headset and looking at this kind of interface, and they can use that to control some music played in the headset, like a pressing button can play the music, and like using the slider bar to change the volume, and using the dial to change the playback speed. So the Maury project is about enabling tangible interaction for AR/VR using some like 3D printing and the Maury effect. But 3D printing is not like widely accessible to everyone. It has become more and more popular right now, but not yet for like universally accessible. So we're starting to think about the problem is that can we build tangible interface using something that is more universally accessible, like paper? So this is one of my latest TI publication. We designed a new visual marker system, as shown here, that allows the camera to track the change of paper. If you print this pattern on the paper, you can track the change of the paper in a very robust way and to integrate that as an interaction signal. And for example, here we show some interaction primitive we enable. For example, so these paper are all printed with this pattern, and you tapping on some location, you can track the tapping location, and also you can do touch tracking, continuous tracking, and also you can detect the appearance change of paper, and also you're able to detect the deformation of a paper. And here we show some application enabled by the design. So first we can just craft paper into some widget structure, like buttons or rotary dial. And if the user is playing an AR game, they can press the button to select the AR character, and also rotating the dial to change size. And also because the paper can deform, this is one of the unique features paper have. We can leverage to build some like a paper strip interface to simulate the effect of like a slider bar. User can push it to deform, and our system can recognize that and convert it into some interaction signal. And I think the paper also can be attached to some like everyday object like the water bottle. And you can, in this application, placing the bottle on top of a screen will trigger a water pouring effect. And when you squeeze that, it can increase the water flow because we can detect the deformation. And also, paper can be attached to your body as a wearable device, like a wristband. And in this scenario, the wristband can function like a remote controller. So when you swipe left and right, you can switch the tab, and also swiping up and down, you can scroll within this tab. So lastly, we are able to understand the 3D geometry of the paper structure. Here we show a security guard staircase, and AR fox is on the staircase, and we can tap some location to allow the fox to move that. And because we understand the 3D geometry, we're able to know that the fox will able to follow the 3D geometry of the staircase. So this is some work on enabling natural interaction for AR/VR, and I also want to briefly talk about some one of my recent work on how the natural interaction can be applied to AI. So this ChatGPT interface, we are all very familiar with that. It's probably one of the most widely used interface at this moment. I personally use a lot. And if you use ChatGPT a lot, you probably will experience some situation like this. You want to ask some simple question, for example, like a recipe, but sometimes the response may be very slow or even get stuck because a lot of people is using ChatGPT, so there's a lot of bandwidth issue, and you also feel you would like to need to wait for the response to appear. So this is because Element is very computationally expensive model. It takes a lot of computational resource to compute in a token by token fashion, and with many people using the system on the same time, the resource may not be enough for you to generate in a faster speed, so you need to wait. But sometimes you may ask questions that expect a very informative and also tactical answer. For example, explaining the Fed's interest rate, how does Fed's interest influence the inflation? And definitely you need some time to process this information. But the LLM may streaming at a speed much faster than you can read. So this is not a huge problem for like a user experience because you can always wait until the stream, you can always read as the streaming comes through. But if many people use the system and you are streaming in a faster speed than you can read, this actually result in some like waste of bandwidth or waste of the computational resource. So in the meantime, some people ask simple questions, they may feel they get stuck or need to wait to the stream to finish. And to address this mismatch, we propose a new cognitive load aware method for adaptive streaming. So the idea is very simple. Given a set of concurrent element requests, we first use a cognitive load prediction model to understand what kind of the cognitive load you might need to process information. And we adaptively modulate the speed to make sure that the paragraph needs a higher cognitive load may stream slower, and also we can pause a little bit to give you some time to process. So and this saved bandwidth, saved computational resource can be reallocated to something that happens simultaneously, which some user may ask some simple question, like just like a pasta recipe. For example, they can just read this very quickly because there's not too much information on that. So by using this, we are able to efficiently organize the computational resource and without compromising any user experience. So this is the main part of the talk. Just one conclusion very quickly. I believe we are living in a very exciting time, especially for HCI researchers with a lot of opportunities. And the advancement of AI allows us to do a lot of new things, like a new sensing method, new ideas like generative interface. That's something that we are not able to do before. But meanwhile, I think it's also very interesting to incorporating or injecting HCI ideas into the development of AI and shaping the AI and steering how AI can develop and to make it fit with the human needs and human use preference. So yeah, thank you again. That's the end of my talk, and thank you. I'm happy to take any questions you have.
Hi, I have a question.
Yeah.
So I also am very much fascinated by physical interfaces, so I have a little bit of a provocation. So you show some natural user interfaces. Among those, there was also a keyboard, which arguably many people might feel it was designed, like QWERTY, at least layout was designed actually not to be necessarily natural and so on. So it seems like a physical interfaces, even the one that we consider really natural, actually are just a product of an evolution.
Yeah.
They are cultural type of evolution, sometimes due to the time, sometimes due to the fact that maybe are familiar to some users. For example, the keyboard is very familiar to me, so it's natural to me, not to my son, he's very young, he doesn't know how to type. So I wonder perhaps, what do you think about the idea that the naturalness of an interface maybe is not a property of the interface itself, but it's a property of the user perception of that interface. So what I mean with this is, when we design, let's say we design a new type of interaction and we consider maybe robots are going to come to play and so on. So at the point when what we define as natural is really only contextualized to our experience. And I wonder if that somehow inspires to you, or what do you think when you talk about natural interfaces in your quest? What is your attempt over there?
Yeah, definitely, that's a great point. So by natural interface, I think there's two levels of natural interface. One is that something we really don't need to learn, like the door handle, like a cat can just use that, and you can, when you see that, you know how to use that. There's not too much flexibility or not too much variability. There's only maybe one outcome if you use that. But also, it's also related to what you mentioned, that there's some learning curve, and also some culture aspect, something that we already already used like 30 years ago, like since the computer has invented, we're using this kind of keyboard layout. Maybe it's not the optimal layout, but it has been used by many users, and they're continuing using that. They may still need some time to use that, but we are not coming up with a new solution, or coming up with a new solution where the overhead is too large that we need to learn a new interface, and we need to abandon that old interface. So I think the natural interface is a complex topic. I cannot say something is natural or something is not, but definitely something if it's easy to use, that is natural interface, but also something that we have adopted by the market, something that has been selected by the market, and people will continue using that. That's also something that I would also consider as the natural interface, because it has a test of time. It has been adopted by many users and adopted by the market. Yeah.
I really like this line of inquiry about what natural is, and Bill Buxton is an inspiring figure about this topic. But one of the things that maybe to pivot the definition is less about being natural and more about being learnable. Also have cats.
Yep.
My doorknobs don't have a handle, they're round, so the affordance, the physical affordances don't allow for learning. It's about learnable things that have constraints that allow you to learn its behavior and predict its outcome. And that is what makes a keyboard something that now feels natural, because we can learn its rules and we can adapt to them. So in terms of the physical or the affordances of the material, on the physical, on the tangible, we know about that well. And having constraints helps us learn that. In the case of AI and things like ChatGPT, I'm curious about the trade-off between something that can be anything. It has really no defined affordances or limits for us to really understand its properties and what can it do, what cannot do. So I wonder what, in your opinion, are the constraints that AI can have that allows us to learn how to use it in a natural way?
Are you more so is your question more like on the AI side? How do we?
For example, in ChatGPT, I can enter anything on it,
Mm-hmm.
anything.
Mm-hmm.
There's no constraint about what I can ask them. So what can it do, what it cannot do? Like, how do I learn its physical boundaries so I can then become a natural user of it?
Yeah.
So, yeah.
Yeah, I personally feel ChatGPT or this kind of AI interaction is already a kind of natural interaction, because it's mimicking a way that you are interacting with a human. Just as when you're asking some question with some your colleague or friend, that's something that you can do to the ChatGPT. So I already feel the interface of the GPT is very natural, and you just replicate how you doing that in the normal society. But I mean, definitely the way controlling the output of the AI is something that I would be more interested to investigate, because the definitely user has different variety of different questions, but AI also have its own ability to generate a variety of answers. And how do we control that in a less harmful way, or less helpful way, or in a way that indeed matches with the user's intent? That's something I think definitely needs some more exploration. And I think it's the time to talk about.
Okay, yeah, thank you very much. Next we have Professor Andrea Bianchi from Chang.